All right, our first video is going to be all about what is a complex number, and working with the real and imaginary part, how can we get answers to different types of problems that we previously would have just said no real solution. We can now start to actually find solutions for them. So when we think about the number system, all the numbers in the world that have been around for years and years and years and years, centuries, okay? We have our natural numbers, which are just the ones that we count. We have our integers, those include 0 and the negatives, okay? Rational numbers are things that can be written as a fraction. Irrational numbers, if you've taken geometry, you've come across pi. We've also come across numbers like the square root of 2. Those are decimals that go on without any sort of repetition or pattern. And then that creates the real numbers. And so everything that we've been talking about says we either have a real number and we get the answer, or we've been saying there's no real solution. Because there is a whole bigger set called the complex numbers, and complex numbers have one part that is real and one part that is imaginary. So if the imaginary part isn't there, we just have a real number. If the real number isn't there, we just have an imaginary number. But if the number has both real and imaginary parts, then we call it complex. And you might be thinking to yourself, that sounds tough. That's why we call it a complex number. It is a complex problem. So, complex number, you've got space in your notes to write down, has A, and that's going to be the real part. So, A is going to be the real part of our complex number. B times I is going to be the imaginary part. And this I, notice it's written kind of like as a little cursive I. That's how I'm going to indicate that we're talking about the imaginary part that goes with it. So complex number, two parts, one part real, one part imaginary. Okay, so here's a nice little joke for you. Because when we talk about the imaginary part, here's me with a unicorn, the imaginary thing that we are talking about is the square root of -1. So when we reference I, that kind of cursive I, we are talking about the square root of -1. So go ahead and write that in. Well, we know from math that if I were to square both sides, this side would just become I squared. And this, when I take the square root and I square it, they cancel each other out. So it stands to reason that I squared would be equal to -1. Okay, so I stands for imaginary. But it's imaginary because we don't really have a way to define the square root of a negative number. So instead of writing the messy square root of -1, we just write this mathematical symbol I to indicate that we were taking the square root of a negative. So our core concept that's in your notes, the square root of a negative number is what's going to create something with an I. Okay, so if you look at this, this is our same way of breaking down square roots that we were doing before. Except now when we break down a number, we're going to end up with an I. So for instance, if I was talking about the square root of -3, I could break that down into -1 times 3, which would be the square root of -1 times the square root of 3. This then becomes I, so I get I times the square root of 3. Okay? So find the square root of the number. I've got some reminders over on the right about different square roots that we know, and we just learned that the square root of -1, hopefully you're saying, is equal to I. So go ahead and fill that in. Find the square root of the number. So we're going to start by breaking these down just like we did the other day. So this would be equal to the square root of -1 times 4. The square root of -1 is I, and then we still have the square root of 4, which is going to be 2. So our final answer is 2I. This comes back as just an imaginary number. The next one, breaking down -12. Well, -12 I could break down into -1 times 3 times 4, which really would be the square root of -1 times the square root of 3 times the square root of 4. Well, this part right here is going to come back as I. The square root of 3 is just the square root of 3. Can't do anything about that. The square root of 4 is 2. So the way that I would write that, you can leave it in that order, but generally as mathematicians, we would write 2I times the square root of 3. So again, that I being there, when I look at that, it doesn't mean the number is not there. It just means that it has a part that is imaginary. All right, we'll keep going. I've got this negative sign. I'm going to break this down into just -1 and 36. So I have -1 times the square root, oops, too big, times the square root of -1 times the square root of 36. So I'm going to have -1 times I times 6. Putting that all together, I would get -6I. Last one, 2 square root of -1 times, I'm going to say 9 times 6. Well, that's going to be 2 times the square root of -1 times the square root of 9 times the square root of 6. This will become 2I times 3 times the square root of 6. Putting together the things that I can, I'm just going to make that a 6I root 6. Okay, so all we're doing is breaking down our square roots, except now we're going to encounter a square root of a -1, and we just replace that part with an I. All right, time for you to try. Go ahead and remind yourself that the square root of -1 is equal to I. So go ahead and pause the video, try these 4 problems, and then come back once you have answers to try to check. Please pause your video. All right, so here's my work with the answers. If you want to go ahead and check through, the one in red, we should have gotten 5I. The one in purple, we got 3I root 2. The one in green was -2I root 10, and the one in blue was 10I root 3. Okay, so go ahead and pause the video if you need to look longer at these slides, but really we should have been able to try these 4 because they look just like these 4. Okay, so we now have 8 different examples that we can look at. When you're asked to take the square root of a negative, you now know how to simplify those down, taking the square root of a negative and simplifying with I. All right, so complex numbers, as I mentioned in the beginning, you don't have this little chart, that's okay. Complex numbers are written as one part that is real and one part that is imaginary. So when we work with this, we can combine the imaginary parts with the imaginary parts, the real parts with the real parts, to create complex numbers. Okay, so remember, the real numbers are the things that we've been working with most of our lives. The imaginary numbers are when there's just i's, okay, nothing being added to it. Complex is when you take one part real and add one part imaginary. So we can add and subtract complex numbers. 8 minus I is a complex number because I have a real part and I have an imaginary part. 5 plus 4I is a complex number because I have a real part and an imaginary part. And so what you want to do is you want to take the real and the real and put those together. Take the imaginary and the imaginary and put them together. And then make sure your final answer is written in the form A plus BI, so the real plus the imaginary. All right, so in thinking about that, we're going to treat these as like terms. That's the phrase I'm looking for. So we're going to combine like terms just like we would in algebra. So I'm going to take the real and the real. I have 8 plus 5 is going to be 13. So I'm done with the 8, I'm done with the 5. Now I have negative I plus 4I. Well, negative 1 plus 4 is going to be plus 3I. My final answer is written in the form A plus BI. That's standard form, so I'm done. This next one, order of operations, says if I take this complex number, here's my real part, here's the real part, here's the imaginary part, Order of operations says that I should distribute this negative sign first. So I'm going to rewrite this as 7 minus 6I minus 3, and then negative times a negative makes a positive. So now when I combine these, 7 and negative 3 makes 4. Negative 6 and positive 6 makes 0. I. So you could leave your answer like this, but if we don't have any imaginary part, we ended up with just a real answer of 4. All right, this one, following order of operations again. So I've got this real, that's it. And I've got this imaginary and this imaginary. So I'm going to go through, I'm going to distribute because order of operations. Okay, so I'm going to have 13 minus 2 minus 7i plus 5i. I'm going to combine my reals, 13 minus 2 is 11. I'm going to combine my imaginaries. Oops, that was supposed to be in blue. Going to combine my imaginaries. Negative 7 plus 5 is a negative 2i. This is in standard form, real and imaginary. A plus bi. Okay, you know what time it is. Time for you to try. Okay, write your answer in standard form. So remember, you're going to do your reals plus your reals, your imaginaries plus your imaginaries, and then your final answer is going to be your reals plus however many imaginaries you had. My pen stopped working. Come back to me. There it is. However many imaginaries you had. This is what we call standard form of a complex number. So go ahead and pause this video and try adding and subtracting our complex numbers. All right, so remember, just like adding polynomials when we have x's, you want to combine like terms. So the 1 and the 5 can go together to make a 6. The negative 4 and the 7i can make a 3i. This one with subtraction, the first thing would just be to make sure that we distribute in that negative sign, following our order of operations, and then I ended up with 2 and negative 6 makes negative 4, negative 3i and positive 10i gets you to 7i. And then for C, distributed in that negative, 12 minus 8, that was my real part, so I got 4. Negative 9 plus 2i was my imaginary part, I got negative 7i. So all three of these came back as complex because they had one part real, one part imaginary. So to summarize, we know how to simplify square roots that have imaginaries in their results, right? So taking the square root of a negative number, the square root of negative 1 is equal to I. And then we also learned how to work with I, so how to add and subtract using i's. All right, go ahead and move on to video 2 once you're ready.